Hello, it's Adrian from the Sofeast team here. Welcome back to China Manufacturing Decoded, episode 125 today. Earlier on, I was speaking with our head of new product development, Andrew, about the dFMEA. That's the Design Failure Mode and Effects Analysis. This is a tool that we use quite a lot at Sofeast and Agilian Technology for product design engineers to de-risk product designs early on. They really get into what can cause potential failure modes. So those are failures like something breaks and you're not expecting it, and then knock that out of the design long before it goes into production. Hopefully, that'll mean that your customers, once they do get their hands on the product, won't suffer from any of those potential failures, or at least it'll be extremely unlikely. So this is a useful tool to understand, and Andrew's going to talk you through what it is, how to implement it, and importantly, 8 secrets that you need to know to successfully implement a dFMEA. Right, let's get into what Andrew's got to say.
So let's discuss what is a dFMEA. Typically, dFMEA stands for Design Failure Mode and Effects Analysis. And it's really a risk analysis process that is typically done early in design and development. Sometimes we call it early in the MPI process. Mm-hmm. And the real purpose of the dFMEA is to de-risk the design so that later on in production and or after the production, you wouldn't have any kind of serious failure modes that can actually either impact the performance and use of the product and or have some kind of catastrophic failure that can cause death or huge impact on users. You know, for example, worst case scenario would be the failure of, for example, a Samsung Note 7. That's a good example of a product that if a successful dFMEA was done, that failure mode should have never occurred. Yeah. However, mishaps happens. Design team and the development team are very, very busy. They have numerous amount of variables and factors that they have to keep in mind. And unfortunately, here and there, sometimes based on the schedule, they may either forget about it and or cut corners in quality and reliability or in testing that would cause some of those failures not to be identified. So the main purpose of the dFMEA is to be able to actually de-risk the design before the development has gone too far. The best time to do the dFMEA is right at, for example, early design. I would recommend probably at the EVT, as we had discussed before, or even in some cases, even earlier than EVT, if there are any way possible to do that. The earlier you do the dFMEA, the better it is, because as you go through the development phase, the longer you're in the development, the harder it's going to be to make changes if the dFMEA identifies that some design areas must be changed in order to avoid any kind of failure risks. So the question is, how would we implement such a process in the development so that it can actually successfully work for the purpose that we want? Well, there is a template usually used for this purpose of dFMEA. Traditionally, it has been done in an Excel format. Let's look at the steps that you must follow. Typically, there are 10 steps that you follow. First, you list each system and function and other design-related requirements. And then you try to find out what are the failure modes for each system or component or design-related that could happen. Third, you try to describe those failures in a manner that everyone within the team understands in terms of severity rating. And again, the ratings could be it's something that the team will decide, and that could be from 1 to 10, or it could be 1 to 100, depending on resolution that you want. And number 4, how to implement the FMEA. Of course, you try to find out the potential root causes of each failures. Number 5, you try to come up with a prevention method of controlling these failures, and you come up with an occurrence rating. And number 6 is you try to have a detection method and detection rating, again, depending on what you decide, 0 to 10 or 0 to 100. And then you have to calculate the RPN number. And the RPN stands for risk priority number. And the way you calculate that is something that a lot of people don't know. And that's actually very, very important. So you basically, from the template, you have given numbers and ratings for severity. Let's say from 0 to 10, you gave 6. And then let's say for risk priority number, for RPN number, for occurrence, you gave a 5. And then for detection, low detection, so you gave it 2. So basically, you have to multiply 6 by 5. That's 30. And then times 2. 30 times 2, and that's 60, right? 60 will be the number. So you just multiply those across severity, multiply by occurrence, multiply by detection, and that becomes risk priority number. And then once you have figured out the risk priority number, all right, then you need to start making some kind of recommendation. That's step number 8. But how do you do that? Okay, this is one of the secrets that we're going to discuss. You need to take those risk priority numbers and you need to sort them from the highest to the lowest RPN number. And the number 9 is, okay, now we have to make a recommendation that those high numbers on RPM need the main attention, the first attention, or high priority attention. And then you work yourself down from the highest priority to the lowest. You need to determine what actions need to be taken place to de-risk these issues, and what dates, who is going to do it, and so forth. And then, of course, number 10, the last item, is to monitor those actions and find out that the risk has actually been reduced. And because of that, you can actually come up with new RPN numbers that can actually completely de-risk the design. So this was, in a nutshell, the step-by-step implementation process. Many design teams, a lot of people know this process is pretty much standard. However, how you implement, how you make sure that it succeeds, that's a different story. So that's what I need to talk to you about and discuss what are the secrets, a few secrets that you must know to be able to successfully implement a dFMEA. Step 1 on the secrets. You must create a team for dFMEA. The team must be a team of experts about the products. Expert, for example, in design, expert in manufacturing, expert in mechanical engineering, electrical engineering, quality, reliability, test engineering, and so on. Because these experts, they know the design well enough that they understand, they agree together what could be failing and what could be the root cause. The second secret, after you have created that team, is you need to have a person who coordinates these meetings and make sure have weekly or bi-weekly meetings and documents all the information, asks the right questions, and basically documents this whole process. Typically, this person would be either from reliability or quality department. The next secret for a successful dFMEA is to make sure that you have a very thorough risk analysis. So it is very possible, for the sake of the time, or maybe you don't have the expert designer in the room, you may miss one of the critical failure modes that could happen, and you don't document it and you don't track it. Oh boy, that would be, big trouble waiting to happen. So it is extremely important that you have the right team members, that you educate them in terms of coordinating the team. You allow them to think, and you make sure they understand it's critical not to cut corners and to discuss freely about any kind of failure modes could happen. In a way, this is called brainstorming. You need to coordinate the team. You need to allow them to brainstorm, but you need to have actual experts. Otherwise, you could miss out on critical failure modes. The next secret is, okay, we figured out what the failure modes are. What do we do next? It's very important that whoever is coordinating these meetings and documenting all the information from every expert, they also have a logical process of discussing with the right questions, because the team under the management of this person is looking at him to guide and manage this process. If he doesn't have the, let's say, the experience in doing a dFMEA, he may not ask the right questions. Therefore, he may not get the right answers, and therefore the dFMEA process would fail. So it is important that you choose a very senior level experienced individual who has plenty of experience in de-risking, risk analysis, and dFMEA process. And he asks the right kind of questions in terms of, okay, well, you mentioned, for example, in this part of the design that this could fail. But what could fail? Could it be just, for example, screw failure that could cause catastrophic failure? Or could be a solder joint? Or it could be a IC failure? What about the wiring? So you must ask these details, whys and whys and whys. Sometimes I call it 5 whys. So to kind of get to root cause of the failures. Then the next step is, one of the other secrets is that, okay, you have the failure modes, you have the root cause, but who's going to implement it? This is the key for actually implementing the FMEA. And over, I have seen companies have went through the trouble of doing the dFMEA, and guess what? No one actually implemented the preventive action plan. And so what happened? Failures happened, as if nobody ever did the FMEA. And so it's very critical and very important that whoever is coordinating and documenting this implementation of the dFMEA, he is also making sure someone or a team is responsible for corrective action, preventive action, rework, whatever you name it. being able to implement these issues so that truly you are de-risking the design. So the next thing is that, okay, you've implemented the process, you know who's going to fix it, and they have already fixed it. What next? It is critical that you test the process based on the dFMEA and to understand what we were thinking that could fail. Is it failing now after implementation of a corrective action plan? So how would you do that? Well, you either design a test. For example, we were talking about overloading the system. Let's do that. Let's overload the system and see what kind of failures will happen, similar to a test of failure. And if none of those failures happened after the implementation of the corrective action plan, wonderful. That failure is no longer happening. Then what do you do at that point? That's the last secret. You must do a de-risking one more time. You have to do another dFMEA, basically follow up on the same one, and then say, okay, before it was high 200 RPM. Now, after the test and after implementation of the corrective action plan, we get in 10 RPM, which is very low. So it becomes almost no risk. And finally, once you have de-risked the process, you have tested, implement, and made sure that these things couldn't happen again, then the final thing that should be happening is you make the product, build the product, and ship it, and then periodically do this test as part of, for example, ORT, ongoing reliability testing. And you could be doing this overload test and or critical tests that are necessary to verify that the process that was implemented is still on target and it's actually effective and working.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.